Okay, hi everyone. I'm going to work through these problems for you, and both of these are just time value of money problems, but the second one's a little tricky. The first one, number 36, says you're thinking of purchasing a house. The house cost $350,000. You have $50,000 in cash that you can use as a down payment, and you need to borrow the rest. The bank is offering a 30-year mortgage that requires annual payments, that's annual, not monthly, and has an interest rate of 7%. What will your annual payments be if you sign up for this mortgage? Okay, now in this section right here that I'm highlighting, that's how you could solve it with the calculations, right? Here's the timeline. We need to borrow $300,000, and then we're going to make payments given by the variable C, and that runs through 30 years. Now, there's the math formula, which you could do, but I wouldn't advise you to do it this way. I would solve it with Excel. I think Excel leaves a great audit trail, and I think it's easy to use. So all we have to use is essentially the payment function. Now, I've worked it ahead for you here. All right, so the present value of the loan amount is the $350,000 less the $50,000, that's $300,000. Number of periods given by N is 30, and the interest rate, which we usually use as an I, it's either a big I or a little I. And then we have to calculate the payment. Now, I've worked this one ahead. I'll just turn that so that you can see how I solved it. But here's what you do. You would hit the equal PMT, hit the left parenthesis, then I come up here and I call up this little function argument, right? And then we start telling it where the variables are. Well, the rate is 7%, given in cell D14. Number of periods is 30, given in cell D13. The present value is the amount of the loan, that's given in cell D12. The future value is going to be 0. We're going to pay it all off. And we can leave the type blank as well. That just asks, is the payment made at the beginning of the year, which would be an annuity due, and you'd make it a 1, or make it 0, or leave it blank for an ordinary annuity. And if they don't tell you the payment occurs at the beginning, you assume it's an ordinary annuity. So I hit OK and I'm done, and I've got 24,176. Now, of course, this is rounded to whole dollars, but that's how you solve this one. Okay? So again, there's the formula right there. You can call it up and check what the various parameters are. All right, now let's look at question 37. You'd like to buy the house and take the mortgage described in problem 36. You can afford to pay only $23,500 per year. The bank agrees to allow you to pay this amount, but you're still borrowing $300,000, and at the end of the mortgage, in 30 years, you must make a balloon payment. That is, you must repay the remaining balance on the mortgage. So how much will the balloon payment be? Okay, now I've put this little image here on the screen that you can look at this point. If you wanted to solve this algebraically, this is how you approach it. And again, we've got a timeline of $300,000. Now our payments are $23,500. And so we've got to figure out what is X in that last period at period 30. And mathematically, you could solve it by setting $300,000 equal to $23,500 divided by 0.07. And then you multiply it times 1 minus 1 divided by 1.07 raised to the 30th power plus that final payment, which would be X divided by 107 to the 30th period. Now, to me, that's harder to understand and harder to work through. On this one, I actually would take advantage of putting together the payment schedule and then just work it out and see what the payment is. And I think that's easier than thinking through and solving it using algebra. So here's what I would do. And I did this ahead of time just to save time in putting together this presentation. So let me move this over. Highlight some of these cells here. Okay, so what do we have? We've got, I got to move this over just a little bit. Maybe make this bigger. Yeah, that'll work just fine. We've got period 0, which is right now, there's our payment, right? And then if I put together period 1, the payment is $23,500. Now, that payment's going to be the same for all 30 periods, right? Take this down, 30. Okay? And the interest is going to be equal to the principal times D14. Well, D14 is just 7%. If I slide up, you'll see it's 7%. Okay? So the principal reduction is going to be the payment amount minus the interest, and then the principal balance is going to be whatever the previous balance was minus the amount of principal reducing. Now, once I have that done, I can just copy all those formulas all the way down. And when I do that, when we go down to the bottom, we see exactly what the last principal is owed at the end of 30 years. Look, it's $63,848, which is exactly what we would have solved using the algebraic way. So that's how I would solve this one. Okay? Okay, I hope you found this beneficial. Thanks, everybody.